Hello, how to solve for s in this equation x minus 1 to the power of 6 is equal to 5 to the power of 6. Solution. Then here we have x minus 1 to the power of 6. If you take this 5 to the power of 6 to this side, it becomes minus 5 to the power of 6 is equal to 0. Now this can be written as s minus 1 to the power of 3 all square minus this can be written as 5 to the power of 3 all square is equal to 0. Then if you look at this is in the form of perfect square. That is, if you have a square minus b square, this is equal to a plus b bracket a minus b. Now where a is equal to x minus 1 to the power of 3 and b is equal to 5 to the power of 3. Then this can be written as s minus 1 to the power of 3 plus 5 to the power of 3 bracket s minus 1 to the power of 3 minus 5 to the power of 3 is equal to 0. From here, there are two cases here. The first case is x minus 1 to the power of 3 plus 5 to the power of 3 is equal to 0. And the second case is x minus 1 to the power of 3 minus 5 to the power of 3 is equal to 0. Now let's consider this first case. From first case, we have x minus 1 to the power of 3 plus 5 to the power of 3. Take note of this, that if you have a to the power of 3 plus b to the power of 3, this is equal to a plus b bracket a square minus ab plus b square. Now where a is equal to s minus 1 and b is equal to 5. So this can be written as s minus 1 plus 5 bracket s minus 1 square minus 5 bracket s minus 1 plus b square, that is 5 square, is equal to 0. Then this can be written as s minus 1 plus 5. This is s plus 4 bracket. If you expand this, we have s square minus 2s plus 1 bracket. Here 5 times s, this is 5s, then minus 5 times 1, that is 5, plus 5 squared, 25, is equal to 0. Then this can be written as s plus 4 bracket s squared minus 2s plus 1 minus times 5s, this is minus 5s, minus times minus 5, this is plus 5 plus 25 is equal to 0. Then here we have s plus 4 bracket, here is s squared, we have minus 2x minus 5s, this is minus 7s, here is 1 plus 5, that is 6, plus 25, as plus 31, is equal to 0. There are two cases here. The first case is s plus 4 equal to 0, and the second case is s squared minus 7s plus 31 is equal to 0. And from here, s is equal to minus 4. This is the first value of x. S is equal to minus 4. This is the first value of s. Now let's consider the second case. If s squared minus 7s plus 31 is equal to 0, this is a quadratic equation which can be solved using quadratic general formula. And from quadratic general formula, s is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. And from this equation, a is equal to 1, b equal to minus 7, c is equal to 31. Then s is equal to minus bracket minus 7 plus or minus square root of minus 7 square minus 4 multiplied by a is 1 multiplied by c is 31 divided by 2 multiplied by a is 1. S is equal to minus times minus 7. This is 7 plus or minus square root of minus 7 squared, that is 49, minus 4 times 1 times 31. 4 times 1, that is 4, and 4 times 3, 12, that is 124, divided by 2 times 1, 2. S is equal to 7 plus or minus square root of 49 minus 124 minus 75 divided by 2, and this is equal to 7 plus or minus square root of minus 75 can be written as 25 multiplied by 3 multiplied by minus 1 divided by 2. Then s is equal to 7 plus or minus square root of 25, that is 5, and square root of minus 1 is I, then root 3 divided by 2. Therefore, s is equal to 7 plus 5i root 3 divided by 2, or s is equal to 7 minus 5i root 3 divided by 2. So these are other value of s from the first case. Now let's consider the second case. Then from here, we have the second case, x minus 1 to the power of 3 minus 5 to the power of 3 is equal to 0. From second case, s minus 1 to the power of 3 minus 5 to the power of 3 is equal to 0. Then take note of this, that if you have a to the power of 3 minus b to the power of 3, this is equal to a minus b bracket a square plus ab plus b square, where a is equal to s minus 1 and b is equal to 5. Now let's compute. Here we have s minus 1 minus 5 bracket s minus 1 square plus 5 bracket s minus 1 plus 5 square is equal to 0. And this is minus 1 minus 5, that is minus 6. We have s minus 6 bracket, if you expand this, we have s square minus 2s plus 1 plus this 5 times s, 5s, then 5 times minus 1, that is minus 5, plus 5 squared, that is 25, is equal to 0. Then here we have s minus 6 bracket s square minus 2s plus 1 plus 5s minus 5 plus 25 is equal to 0. S minus 6 bracket s square minus 2s plus 5s, that is plus 3s, then 1 minus 5, that is minus 4, then plus 25, that is plus 21 is equal to 0. There are two cases here. The first case is s minus 6 equal to 0, and the second case is s square plus 3x plus 21 is equal to 0. And from the first case here, s is equal to 6. This is another value of x. Then from here, we can use quadratic general formula. S is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. And from this equation, a is equal to 1, b equal to 3, c equal to 21. Now s is equal to minus 3 plus or minus square root of b is minus 3 square minus 4 multiplied by 1 multiplied by 21 divided by 2 multiplied by 1. Now s is equal to minus 3 plus or minus square root of 3 squared, that is 9, minus 4 multiplied by 1 multiplied by 21. 4 times 1, that is 4. 4 times 2, 8, 84, divided by 2 times 1, 2. S is equal to minus 3 plus or minus square root of 9 minus 84, that is minus 75, divided by 2. Then from here, s is equal to minus 3 plus or minus square root of 25 multiplied by 3 multiplied by minus 1 divided by 2. Then x is equal to minus 3 plus or minus square root of 25 is 5. Then minus square root of minus 1 is I root 3 divided by 2. Therefore, s is equal to minus 3 plus 5I root 3 divided by 2, or s is equal to minus 3 minus 5I root 3 divided by 2. These are other values of x. Then our answers are x1 is equal to minus 4, then s2 is equal to 6, s3 is equal to 7 plus 5I root 3 divided by 2, then s4 is equal to 7 minus 5I root 3 divided by 2, x5 is equal to minus 3 plus 5I root 3, and x6 is equal to minus 3 minus 5I root 3. You can see that we have 2 real solutions and then 4 complex solutions. Then here, this is complex root. And this is also complex root. This also is complex root. And lastly, this is a complex root. We can check to confirm if our answer is right or wrong using these 2 real roots that we have, minus 4 and 6. Let's check. To check, we have the given equation x minus 1 to the power of 6 is equal to 5 to the power of 6. Then when x equal to minus 4, this is minus 4 minus 1 to the power of 6 must be equal to 5 to the power of 6. Then this is minus 4 minus 1, that is minus 5 to the power of 6 must be equal to 5 to the power of 6. And minus 5 to the power of 6 is equal to 15625, which is equal to 5 to the power of 6 is 15625, which is true at s is equal to minus 4. We may also check to confirm when s is equal to 6. To check, we have the given equation s minus 1 to the power of 6 is equal to 5 to the power of 6. Then when x is equal to 6, this is 6 minus 1 to the power of 6 must be equal to 5 to the power of 6. And 6 minus 1 is equal to 5 to the power of 6, which is equal to 5 to the power of 6, which is true at s is equal to 6. I hope you enjoyed the video. Thank you for watching. Please don't forget to like, share, comment, and subscribe to my channel. Bye.